Another way to represent domain and range in continuous data is on a number line, just like we did last time. Okay? It's a little bit different this time in that we can't just put dots on the graph, right? I guess you could try. I'm going to do all real numbers between 0 and 20 using dots. Let's see if I can do this. Okay? So I would have 0, I'll use red. I could have 0, I'll use yellow. That's a little easier to see. 0 for the third time, and 1, and 2, and 3, and 4, and yeah, those all count. What about in between 0 and 1? Well, yeah, I could have 0.5. I could also have like 0.25, and maybe 0.33, and 0.4, and 0.01, and I could just put as many dots as I please between 0 and 1, and I'd never actually stop putting dots. I just put a whole whack of dots forever and ever and ever. To indicate that I want to include all values between not only 0 and 1, but 0 and 20, I just draw a line between those two. Right? So I'm going to put a closed dot on 0. On 0. A closed dot, I'll explain what that means in a moment. All the way up to 20. There's 20. I'm going to put another big fat dot there. The reason why I do that is because a closed dot on a number line means it includes the dot or the point that it's on. So I want this to include 0, and I want it to include 20, so I close those dots on the endpoints. If it was an open circle, it excludes that value, or it doesn't include it in the set. But I want them to be included, so I close the dots. Okay, range is everything between 15 and 208. So 15 is right here. Alright, just for clarification, this is 15. And that goes all the way to 208. Keep my line going. All the way to right here, and another big dot to indicate that I am including 208. Okay, so there is domain and range in number line format. I just labeled 15 and 208 there because they're not labeled on the number line. Alright, next one here, we have something called interval notation. This is a new one for you. We haven't looked at this yet, but it's fairly simple. Okay, remember domain represents the variable t, and t is the time, and we use time between 0 and 20. So how do we do that with interval notation? Well, what we first do is rewrite the lowest value in our domain, in this case 0, comma, the highest value, 20. Now if I want my domain to include this lowest value, I write a square bracket, like that. If I wanted it to exclude or not include 0, I would write a round bracket like that. Okay, but that's not the case here. I want it to include 0, so I write a square bracket. I want it to also include 20, so I write a square bracket. Alright, if I didn't want to include it, I'd write a round bracket. But I do want it to include 20. So what this communicates here is it's all values between 0 and 20, inclusive of 0 and inclusive of 20. Okay? It doesn't say anything, this is kind of a disadvantage of interval notation. It doesn't say anything about what kinds of numbers exist between 0 and 20. Like, are we talking about natural numbers? Are we talking about integers? What are we talking about? Okay? That's kind of one of the weaknesses of interval notation. But it is an efficient and quick method, and usually you use it when you're talking about a range of values where everything in between is a real number, which we have in this case. Range, you'll remember, is the height, which is an h, not a t, and that goes from 15 all the way up to 208. So we write the lowest value first, 15, the highest value next, 208. I want the range to include 15, so I put a square bracket, and I want it to include 208, so I put another square bracket. Alright? So that's interval notation.